let's see these points on the chromatic number. If xi of h is less than xi of z is equal to k, which means if a graph is having a chromatic number k, then for every proper subgraph h of g, then g is k critical. So what they are trying to say by this point is, if we have a graph and let us say the chromatic number of this graph is some k, then if you try to delete either a vertex or an edge or both, anything, if you try to delete anything from the graph, then for the resulting graph, subgraph, that is called as a proper subgraph, for the resulting subgraph the chromatic number should be less, right? So if you have such a graph, that is called as k critical graph. So see this, what is this? If xi of h is less than xi of z for every proper subset of g, for every proper subgraph h of g, right? So this point is saying that whatever subgraph you take, for all of them, the chromatic number should be less. Now in this example, if you check it, this is 3 colorable. It is 3 colorable because you definitely need 3 colors to color it properly, right? You cannot color it properly using 2 colors. That is why it is 3 colorable. And now the chromatic number of this graph is 3. So what is the meaning of it? You will never be able to color it properly with 2 colors, right? This is the minimum number of colors required to color it properly, right? And now if you delete anything from it, let us say I delete vertex 2. If I delete vertex 2, both the edges are also gone and you get this, right? Then how many colors I need to color it? 1 and let's say 2 and let's say 1 and 2, that's it. Got it? So the number of colors required to color it is reduced. You take any proper subgraph, you need not go for 3 colors, you can color it with 3 colors. If you have such a graph, then that graph is called as critical. Okay, now the clique number of a graph G, W of G, is the maximum size of the pairwise adjacent vertices in G. So what is a clique number is, if you have a graph, in that graph, inside that graph, you search for a maximum possible complete graph. If there is any complete graph which is present inside a graph as a subgraph, that is called as the clique. Only thing is that should be as maximum as possible, right? Now find out the number of vertices in that graph, then you are going to get it as W of G. Okay, now for every graph, xi of z is greater than or equal to W of z, right? So what is the meaning of this one is, first in order to understand this, you should understand one rule, that for a complete graph Kn, the chromatic number is always n, right? So why? In K2, if you see it, two vertices are adjacent to each other, therefore color it with 1 and color it with 2. In K3, 3 vertices are adjacent to each other, therefore you should use 3 different colors, right? In K4, all the vertices are adjacent to each other, all the 4 vertices, therefore you cannot use the same color 2 times, you have to use all different colors. Why? If you use the same color 2 times, definitely you are going to apply the same color to 2 vertices which are adjacent. Why? Every vertex, every pair of vertices is adjacent there. Therefore, chromatic number of Kn is always n. Okay. Now, what is a clique? Clique is a complete graph which is present inside a graph, right? And now once you find out the number size of that clique, which is nothing but omega of G, now once you find it out, your chromatic number is definitely going to be greater than or equal to that. Why? Because for this clique itself, which is a complete graph, you need to color it with those many vertices which are present inside the clique. Apart from this, in the graph there will be other vertices as well. In order to color them, you might need more colors. Therefore, in worst case, you need at least as many as this. Got it? And sometimes you might even require more. Okay? And the next one is, if you can divide your graph into many independent sets. Let's say you are able to divide the graph into independent sets. What is independent set is, in those independent set means, in that set no 2 vertices are adjacent to each other. So for every independent set you should be able to use only one color and no more, right? So now if you can find out the number of independent sets in a graph, then your chromatic number will be greater than or equal to number of independent sets. The reason is, for every independent set, if you give one color, that is enough. Got it? So now let's try, let's see how to find out the independent sets. We might not be able to find out the exact number of independent sets, but we can come with a rough estimate. Now if D of G represents the independence number, we have discussed about this independence number earlier, and N of G is the number of vertices in the graph. N of G by D of G will give you a rough estimate of how many independent sets will be there, right? For every independent set, if you apply one, let us say color, then how many ever are remaining vertices, therefore in order to cover them, you might have to apply more colors. Therefore your chromatic number is always greater than or equal to this number. Got it? Okay.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177. And IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into universities better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply. And statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is, we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.